Section 6.2 is trig functions and specifically using the unit circle. So this first slide is just a comparison of standard radian measurements with their degree measurements. This is a unit circle. It's an important part of trigonometry. I would pause the video and copy this down before I start to explain it. So there's some things you need to know about the unit circle. First off, it's a unit circle, which means that the radius of the circle is equal to 1. Okay. On this unit circle, there's a few different pieces of information. The first is angle measurements in degrees. So this is assuming that the initial side of the angle is on the positive x-axis. So if you had an angle that had initial side of the positive x and the terminal side came out to here, it would have a 45-degree angle. In red are the angle measurements in radians. Okay, so a 45-degree angle is the same thing as a pi/4 radian angle. And then in purple are the xy coordinates for those given points. So if you have a point on the unit circle at an angle of pi/4, it would have the coordinate points √2/2, comma, √2/2. So there's some ways to remember these things. You have to have these memorized, the degree measurements, the radian measurements, and the x and y coordinates. So first off, with the radian measurements, there are only a couple denominators. You have an over 6, over 4, over 3, and over 2. And then they just repeat. The over 3s are always closest to the y-axis. The over 6s are always closest to the x-axis. And then the over 2s are at the what we call quadrantal angles, or at the corners. You could think of 0 as 0 pi/2, 1 pi/2. Pi is the same thing as 2 pi/2, so you can consider those over 2s also. For the numerators, there's some tricks. So for the first quadrant, the numerator of the radian is always 1. 1 pi/6, 1 pi/4, 1 pi/3. In the second quadrant, the numerator is always 1 less than the denominator. 2/3, 3/4, 5/6. In the third quadrant, the numerator is always 1 more than the denominator. 7/6, 5/4, 4/3. And then in the last one, you add across for the numerator. So 5, if you look across, you get 2 plus 3 is 5. For the 7 pi/4, if you add across, 3 plus 4 is 7. For 11, 5 plus 6 is 11. So if you add across, you get the numerator for the fourth quadrant. The coordinate points repeat themselves. So over 3s are always going to be the same coordinates, okay, for their x's and y's. Over 4s are always going to have the same ones. Over 6s are always going to have the same ones. It's just a whether of positive or negative. So your quadrantal angles is either going to be 1, 0 or 0, 1, and then just positive or negative depending. Okay, so this point out here at 0 or 2 pi is 1 out in the x direction, and we haven't gone up or down at all, so 0 in the y direction. For the others, there's only, every denominator is 2, and then your numerators are either √1, √2, or √3. Okay, √1 is just 1. So for over 6s, okay, your x is bigger because you've gone farther out in the x direction and smaller in the y direction. So your x is bigger and your y is smaller. For over 4s, you go the same distance x as you do y, so they're 2s. And then for over 3s, you go out less than you go up, so your x is smaller than your y. So you have the same denominator, they're all over 2, and then it's just either √1, which is just 1, √2 or √3 for all of the numerators, and then they just repeat. So pi/3, you have 1/2, comma, √3/2. 2 pi/3, you have -1/2 because you're in the second quadrant, and √3/2. So you'll start to pick up these patterns to help you memorize the unit circle, but this is something that you need to have memorized.